Welcome to the logarithm presentation. Let me write down the word logarithm just because it is another strange and unusual word like hypotenuse, and it's good to at least see it once. Let me get the pen tool working. Logarithm. This is one of my most misspelled words. I always actually, I went to MIT, and actually one of the a cappella groups there, they were called the logarithms, like rhythm, like music. But anyway, I'm digressing. So, what is a logarithm? Well, the easiest way to explain what a logarithm is to first, I guess, is just to say it's the inverse of taking the exponent of something. Let me explain. If I said that 2 to the third power, well, we know that from the exponent modules. 2 to the third power, well, that's equal to 8. Once again, this is a 2, it's not a z. 2 to the third power is 8. So it actually turns out that log, and log is short for the word logarithm. Log base 2 of 8 is equal to 3. I think when you look at that, you're starting to say, oh, that's starting to make a little bit of sense. What this says, if I were to ask you what log base 2 of 8 is, this says 2 to the what power is equal to 8. So the answer to a logarithm, you could say the answer to this logarithm expression, or if you evaluate this logarithm expression, you should get a number that is really the exponent that you would have to raise 2 to get 8. And once again, that's 3. Let's do a couple more examples, and I think you might get it. If I were to say log, what happened to my pen? Log base 4 of 64 is equal to x. Another way of rewriting this exact equation is to say 4 to the x power is equal to 64. Or another way to think about it, 4 to what power is equal to 64? Well, we know that 4 to the third power is 64, so we know that in this case, this equals 3. So log base 4 of 64 is equal to 3. Let me do a bunch of more examples, and I think the more examples you see, it'll start to make some sense. Logarithms are a simple idea, but I think they can get confusing because they are the inverse of exponentiation, which is sometimes itself a confusing concept. So what is the logarithm, or log base 10 of, let's say, 1 million? Put some commas here to make sure. So this equals question mark. Well, all we have to ask ourselves is 10 to what power is equal to 1 million? And 10 to any power is actually equal to 1 followed by the power of, if you say 10 to the fifth power, that's equal to 1 followed by 5 zeros. So if we have 1 followed by 6 zeros, this is the same thing as 10 to the sixth power. So 10 to the sixth power is equal to 1 million. So since 10 to the sixth power is equal to 1 million, log base 10 of 1 million is equal to 6. Just remember, this 6 is an exponent that we raise 10 to get the 1 million. I know I'm saying this in 100 different ways, and hopefully, one or two of these million different ways that I'm explaining it actually will make sense. Let's do some more. I'll do even a slightly confusing one. Log base 1/2 of 1/8. Let's say that equals x. So let's just remind ourselves. That's just like saying 1/2, whoops, 1/2, that's supposed to be parentheses, to the x power is equal to 1/8. 1/8. Well, we know that 1/2 to the third power is equal to 1/8. So log base 1/2 of 1/8 is equal to 3. I'm going to do a bunch of more problems. What is Actually, let me mix it up a little bit. Let's say that log base x of 27 is equal to 3. What's x? Well, just like what we did before, this says that x to the third power is equal to 27. Or x is equal to the cube root of 27. And all that means is that there's some number times itself 3 times that equals 27. And I think at this point you know that that number would be 3. X equals 3. So we could write log base 3 of 27 is equal to 3. What is, let me think of another example. I'm only doing relatively small numbers because I don't have a calculator with me and I have to do them in my head. What is log, let me think about this. What is log base 100 of 1? This is a trick problem. So once again, let's just say that this is equal to, let's say that's equal to question mark. So this says, so remember, this is log base 100 of 1. So this says 100 to the question mark power is equal to 1. Well, what do we have to raise? If we have any number and we raise it to what power, when do we get 1? Well, if you remember from the exponent rules, or actually not the exponent rules, from the exponent modules, anything to the 0th power is equal to 1. So we could say 100th to the 0 power equals 1, right? So we could say log base 100 of 1 is equal to is equal to 0, because 100 to the 0th power is equal to 1. Let me ask you another question. What if I were to ask you log, let's say base 2 of 0? So what is that equal to? Well, what I'm asking you, I'm saying 2, let's say that equals x. 2 to some power x is equal to 0. So what is x? Well, is there anything that I can raise 2 to the power of to get 0? No. So this is undefined. Undefined, or no solution. There's no number that I can raise 2 to the power of and get 0. Similarly, if I were to ask you log base 3 of, let's say, -1. And we're assuming we're dealing with the real numbers, which are most of the numbers that I think at this point you have dealt with. There's nothing I can raise 3 to the power of to get a negative number, so this is undefined. So as long as you have a positive base here, this number, in order to be defined, has to be greater than, it has to be greater than or equal, well, it has to be greater than 0, not equal to. It cannot be 0 and it cannot be negative. Let's do a couple more problems. I think I have another minute and a half. I think you're already prepared to do the level 1 logarithms module, but let's do a couple of more. What is log base 8? I'm going to do a slightly tricky one, of 1/64th. Interesting. We know that log base 8 of 64 would equal 2, right? Because 8 squared is equal to 64. But 8 to what power equals 1/64? Well, we learned from the negative exponent module that that is equal to -2. Right? If you remember, 8 to the -2 power is the same thing as 1/8 to the 2 power, 8 squared, which is equal to 1/64. Interesting. I'll leave you this to think. I'll leave this for you to think about. When you take the inverse of what you're taking the logarithm of, it turns the answer negative. And we'll do a lot more logarithm problems and explore a lot more of the properties of logarithms in future modules. But I think you're ready at this point to do the level 1 logarithms set of exercises. See you in the next module.